Hi there, Addie. We are going to do lesson number 29 today, and it starts on page 121 if you want to follow along. Today, we are going to talk about negative exponents, and then we're going to talk about zero exponents, but that's going to be super easy. It'll take 30 seconds literally, and then you're going to have it down. Okay, first of all, according to my chocolate advent calendar, there are only 3 days till Christmas. That would totally happen if I had a chocolate advent calendar. I'd be like this. Remember this episode? That was one of the funniest ones, huh? All right, let's get into negative exponents. Here we go. So it's convenient to have an alternative way to write the reciprocal of an exponential expression. So here we show a way to write 1 over 5 squared. Okay, if we have 1 over 5 squared, another way that we can write that, you won't get it at first, but just listen and then you'll get it. 1 over 5 squared is the same as 5 raised to the negative 2 power. Okay, just accept it for now. Look what we did. We moved the 5 from the bottom to the top, and we changed the sign of the exponent. And these two are the same things, these two expressions. Okay, what if we have something like this, and we want to write another way of saying that? This is the same thing as 5 squared. I mean, 5 squared, you're used to seeing stuff like that, right? 5 squared is the same as 5 times 5, which is the same as 25, right? But if you want to write 5 squared in a different way, it can be 1 over 5 to the negative 2 power. So the formal definition of negative exponents, I've got this little GIF there because this is the formal way of doing this. The definition of x raised to the negative n power, this is it, okay? If n, so remember n is the exponent, so if n is any real number and x, that's your base right there, is any real number that is not 0, then 1 over x to the n is the same as x raised to the negative n power. Okay, let's try it a couple times, and then I'll show you how we do problems with that sort of thing in it. Okay, so here's a bunch of examples. What if we're doing 1 over 3 raised to the 4th power? Okay, so we could write that in a different way. Let's move this base from the bottom to the top, and let's just put 3 raised to the negative 4 because we're changing the sign of the exponent. Okay, let's do B. 7 raised to the negative 2 power. So if this were a fraction, it would be 7 over 1. So I can take that 7 and move it to the denominator. So it would be 1 over 7, and then I change the sign on that exponent. So this is the exact same thing as this. Cool, okay. And then let's do C. 1 over 5 raised to the negative 8 power. We're going to move that 5 to the top and change the sign of the exponent. That's the same as 5 raised to the 8th power. Okay, let's do D. D, this is 6 raised to the negative 3 power. That's the fraction. Let's move the 6 to the bottom, 1 over 6, and change the sign of the exponent. 6 raised to the 3rd power, 1 over 6 raised to the 3rd power. Okay, so basically what we do is we are moving the base from the numerator to the denominator, or the denominator to the numerator, and then we are changing the sign of the exponent, and it will be exactly the same thing. Okay, all right, now if the exponent is positive, like this one, then in the reciprocal form, this is considered the reciprocal form, the exponent is going to be negative. If the exponent starts out negative, like in B, look at B, Here we're starting with 7 raised to the negative 2, so the exponent is starting out negative. Then when we do the reciprocal, the exponent is going to end up being positive. Okay, let's try this a couple times. Let's try it. Let's see. Oh, okay, so I told you the formal definition. This is the more informal definition, okay? So a number or a variable, so it doesn't have to be 7 raised to the 2 power. It could be x raised to the 2 power, right? So a number or a variable that is written as an exponential expression can be written in reciprocal form if the sign of the exponent is changed. Okay, you should pause that and read that one more time and make sure that you get it. So an exponent starts out positive, the reciprocal form, it's going to be negative. If the exponent is negative, in the reciprocal form, it's going to be positive. Okay, let's just do some examples and I'll show you. One more. Sorry, one more definition, but this one is even more informal. That's why I put this guy. Yee! He's the most informal. Basically what you do is you move the base from the top to the bottom and you change the sign of the exponent. Okay, that's the most informal. You could also be moving the base from the bottom to the top and you still change the sign of the exponent. That's the easy way to do these problems, okay? So let's do example 29.1. It's on page 121 at the bottom. It says simplify 3 raised to the negative 2 power. Now, if we're doing a problem like this, I mean, we know how to do 3 squared, right? It's 3 times 3. But how do you do 3 raised to the negative 2 power? I mean, that's kind of meaningless. You can't multiply this by itself negative 2 times. What do you do? That doesn't even mean anything, right? So a negative exponent is basically meaningless as far as telling you what to do or how to figure that out. So the first step when we do a problem like this is to write this in a reciprocal form so that we change the negative exponent to a positive exponent. So what I'm going to do is rewrite this in reciprocal form. Since the 3 is on the numerator, I'm going to change it to the denominator. 1 over 3, and I'm going to change the sign of the exponent to a positive 2. So this is the same as 1 over 3 squared. Now, that doesn't mean that we're done. That just means that this is the same as that. Now we can figure out how to do this. So 1 over 3 squared is the same as 1 over 3 times 3, and it's the same as 1 over 9. And that's going to be my final answer, 1 over 9. Okay, cool. All right, let's do this. We got a couple more examples to go. Let's do example 29.2. Here's the problem. 1 over 3 raised to the negative 3 power. Again, that negative exponent, I can't do any math with that. It's meaningless. So I have to change this into its reciprocal form. Since the base is on the bottom, on the denominator, I'm going to move it to the numerator and change the exponent to a positive 3. Now this is just 3 cubed. We know how to do that. We just do 3 times 3 times 3. And when you do the math on that, you'll get 27. And that is the final answer. Let's do example 29.3. In this example, this is really getting tricky because there's a lot of negatives. They've got this in parentheses here, this negative 3, and then they've got a negative exponent. It's this guy that makes me realize I have to write the reciprocal of it because otherwise, what do you do with that? You can't multiply this negative 2 times by itself, right? That doesn't even make any sense. So the fraction is kind of like here. So I'm going to move this part from the numerator to the denominator. Okay, so this is going to be 1 over negative 3. And now I'm going to square that, change that negative 2 to a positive 2. All right, now this is the same as 1 over negative 3 times negative 3. What's negative 3 times negative 3? It's just 1 over 9 because a negative times a negative is a positive. So that's my final answer, 1 over 9. All right, so we've defined negative exponents So one thing to point out is that it does not conflict with our product rule for exponents. Do you remember what the product rule is? Don't remember if you don't. I don't really remember any of that. It's okay if you don't, because here it is. Here is the product rule for exponents. When you're multiplying two numbers or variables, and those two numbers have exponents with them, and the bases are the same, what you do is you add up the exponents, right? So if you have x cubed and you're multiplying it by another x, which is just a 1, you're going to end up with x to the 4th. How did I get that? Because I just added up these exponents. That makes complete sense. But what if you've got a problem and you end up with a negative exponent here? Does the product rule for exponents still work? And the answer is yes. Let's show it. Let's do some examples here. If the bases are the same, like they are in this example, so the bases are the same, meaning that you've got an x here and an x here. And since they're written this way, these two things are multiplied by each other. When they're multiplied by each other, we just add up the exponents. So when we add that, -5 plus 2 is -3. And this would be the answer. Got it? Okay, so the product rule for exponents still applies. Let's do another one. What if you have all these y's? You've got 7 y's here, you've got 5 y's here, and now you've got -2 y's. So you just add those up. 7 plus 5 is 12, and then you've got -2, so 12 minus 2, and you end up with y raised to the 10th power. Let's do another one just to make sure that we've got it. We've got p raised to the 10 times p raised to the -15. So we've got 10 p's here and we've got -15 p's here. How many do we end up with? -5 when you add those exponents together. And that's the answer. All right. I know you're thinking, are you done with this lesson yet? Don't worry, we're getting there. This is fun. Enjoy it. Let's do example 29.4. We're going to simplify this guy. Woo, you can see this is starting to get a little complicated, isn't it? Now, one of the bases is an x, then we've got another one here that's an x, and then you've got another base that's an m. So the first thing I'm going to do, since these are all multiplied together and it's all just in one term, it doesn't matter which order you put it in, right? Because you can move things around because it's just multiplication. But now when I do that, it's easier to do, right? Because I can combine these x's and get x raised to the what? Well, we're just going to do 4. We've got 4 x's here. We've got -2 x's here. So 4 minus 2 is just 2. And now what about the m's? We've got -5 m's here, and we've got +2 m's here. So we're going to end up with m to the -3 when you just add those together. And that's it. That's the final answer of how you would simplify that problem. All right, should we do another one? Let's do it. Let's do this. All right, woo, look at how complicated this is getting. Woohoo! This is tricky. They are trying to be tricky, but you know what? They are just trying to intimidate you because it's not really that hard at all. The first thing I'm going to do is I'm going to put all the x's together because that helps me keep it good in my mind. And the other first thing that I do is I sort of scan across the whole thing and make sure that there's no like plus signs. Like this is all multiplied by each other. So it makes sense that I can just move things around because it's just multiplication, right? All right, now I've got this. So let's start with the x's. How many x's do we have? We've got 1 here. 1 plus 4 x's, that's 5, minus 2. So this is going to be x to the 3. Yep, x to the 3. Now let's do the y's. You've got negative 6y's here, and you've got positive 5y's here. So negative 6 plus 5, we're going to have y to the negative 1. Now let's do the z's. We've got 1z here, and then we've got 5z's here, so that makes 6z's. All right, we've got it, right? All right, now we are going to leave this topic. Yeah, look how cute. That is so cute. Okay, and let's go over zero exponents. All right, now all of that is true. Everything we just did is totally true as long as there are not zeros in the exponent. But I'm going to show you something about zero exponents that's really cool. And the first thing I'm going to show you is a magic trick, okay? So here we've got the number 1. And you know that if anything is over itself, like a 3 over 3, that's the same as 1. Or a 2 over 2, you can simplify that to the number 1. What about 4 squared over 4 squared? Yeah, this totally simplifies to be the number 1. But with that thing that we just learned about something like this, we can write this expression as its reciprocal. What happens when we do that? If we do that, then we have this 4 squared on the top, so we've got 4 squared, and we can move this one from the bottom to the top. And what happens when we do that? When we do that, it becomes 4 raised to the negative 2 power. So this expression is the exact same thing as this expression based on what we just learned. And we also reminded you of the product rule for exponents. These bases are the same, and we're multiplying these things together. So what would we do with the exponents? We would add them together. Here you've got 2 4's, and here you've got negative 2 4's. And when you add them together, you get 4 raised to the 0 power, because negative 2 plus positive 2 is 0. So this is our answer. Let's look at that for a minute and realize that 4 raised to the 0 power is the same as this, which is the same as the number 1. So 4 raised to the 0 power is the same as the number 1. And it turns out that anything raised to the 0 power has to be equal to the number 1, because it would be like doing this, putting a fraction over itself. So anything, any variable, any number raised to the 0 power is just 1. That's the magic trick. This is 1 because 4 squared over 4 squared is 1. And anything raised to the 0 power is 1. So what if you have something really complicated like this? These are parentheses here, and this is raised to the 0 power. Guess what? It's 1. What if you have these, p times m, and it's raised to the 0 power? Easy, 1. What if you have a really complicated thing inside parentheses like px raised to the negative 4, and then that's raised to the 0 power? Guess what? 1. I love these. So a lot of times the first thing that you're going to do is you're going to look for this 0 power in a problem, because if it's there, you can just cross that all out and make it a 1. And it makes it so much easier. Some of those complicated problems will become very simple. Here's the definition. If x is any real number, then x raised to the 0 power is 1. This is in a thought cloud. You have to just memorize this concept. Anything raised to the 0 power is 1. Okay, let's do example 29.6. It's on page 123 if you're following along, and we're going to simplify some of these expressions. Okay, let's start with A. We're going to simplify this guy. All right, the first thing I'm going to do is I'm scanning across. I don't see any like plus signs or minus, so I know that these are all multiplied by each other. So I'm going to take this and rearrange it. So now it's a little easier. I've got my x's here. So x, and what's the power going to be? -2 plus 2, so it's going to be 0. Because -2 plus 2 is 0. Let's do the y's. So I've got the y's here. I've got 5 y's, and then I've got -2 y's. So I end up with 3 y's. And check it out. We're going to use that something raised to the 0 power. This, it doesn't matter what x is. It could be 1, it could be 3, it could be 5/6. This simplifies to the number 1. And when you simplify to the number 1, it's like it's not even there, right? So the answer is just y raised to the 3rd power. Cool, huh? This whole big old thing just simplified to that. That's awesome. No wonder Betty White is fainting over there. Let's do the next one. Okay, I'm going to erase this part so it's not distracting. This is B. Again, I'm scanning across. I'm making sure they're all multiplied by each other, which they are. And once I see that, I'm going to rearrange so the B's are together, the M's are together. Okay, let's start with the M's. How many M's are we going to have? Well, there's 5 M's here, and then there's 1 M here. 5 plus 1 simplifies to M raised to the 6th. Okay, now let's do the B's. Okay, we have a -2 B's here, -2 and plus 2 B's here, so it's going to be B raised to the 0 power. But again, that simplifies to the number 1, so we can just get rid of it, and our answer, final answer, is M raised to the 6th power. Easy. The only problem with anything raised to the 0 power is that thing can't be 0. Like the M can't be 0. So if you have 0 raised to the 6th power, 0 raised to the 0 power, you can't have a 0 in that base because that leads to problems. I don't know. It's like when you multiply 0 by this whole expression, the whole thing becomes 0, right? But then 0 raised to the 0 power is 1, right? So it's just, you just can't have a 0 there. It would be like an unknown answer. Like it just doesn't make sense. So that's the only exception to that. Okay, but it's not that hard. Okay, look at this problem and you might be like, oh my heck. This is really hard, but it's actually not going to be that hard. Let's take an overall view of what's happening in the problem. You've got something outside the parentheses there. You've got parentheses here, but then inside the parentheses, don't lose track of this. This is a minus sign. It could be a plus sign, like plus and negative, right? I mean, just know that it's there because this is not all multiplied by itself like the previous problems. This one's a little different, so we have to do a little more math. But the first step is to sort of simplify everything. And one thing that simplifies it is go around and look for these guys. These guys we can just get rid of and make it a 1. And when you make it a 1, you basically just get rid of it. So I've already simplified this problem, and this is the same thing. Now they want us to use the distributive property here, which if you remember what that is, when something is outside the parentheses, we multiply it by this, and then we multiply it by this, and we basically add those things together. All right, so let's start with this times this. And when I multiply that out, what I'm going to get is x to the 5th z times p to the -3. Does that make sense? It's just this times this. Now I'm going to bring down this minus sign, and I'm going to multiply this times this term. Okay, so when I do that, I like to put the 4s first. I don't know, that's just me. And then let's combine the x's. So here I'm combining x to the 5th and x to the -5th. Oh, look, check that out. If you add the exponents there, it's going to be 5 plus a -5, which is 0. We're going to be simplifying that in a minute, I can tell. All right, but let's finish the distributive property because we still need to multiply the z's, this times this. When there's no exponent, you remember that it's like having a 1 right there as the exponent after that first z. So z, I've got 1z here, and I've got negative 1z here. Oh, check that out. That's also going to be z to the 0. So this is my answer, except I can simplify it further because these guys simplify to 1, the number 1. So it's like that. And that's my final answer. This is it. This is as much as I can simplify, and that's the final answer. Cool. All right, let's do example 29.8. And again, they want us to use the distributive property. Look at these complicated problems that you're doing. Oh my heck, Addie, this really went complicated quickly, didn't it? Like just a few weeks ago, you were like, is this as hard as it gets? But this is pretty hard. So they want us to use the distributive property here. So I'm taking a bird's eye view of this. This is very similar to the last problem where we have something, whoops, outside the parentheses. We're going to multiply it by this, and then we're going to add and multiply those two terms together because you've got two terms inside the parentheses that are added. Make sense? Distributive property. So the first thing I'm going to do is multiply. Well, the first thing I'm going to do is I'm going to look for any x to the zeros because I like those. I can just get rid of them, but there's not any. Dang it. That's okay. Let's do this times this first. If I focus on the x's, I've got x to the minus 2 here and x to the positive 2 here. Oh, sweet. This is going to end up being x to the 0. Now let's multiply those y's. Y to the minus 2, y to the positive 2. Check it out. It's going to be y0. I'm just going to leave it like that for now and simplify those later. All right, so I did that first term of the distributive property. Now I'm going to multiply this guy times this guy. All right, and I'm going to bring that plus sign down, okay? And I like to put the exponent or the coefficient first. It's the coefficient. And then let's multiply the x's. So over here, I've got negative 2x's and I've got positive 4x's. So that's going to be x squared down here. Now let's multiply those y's. I've got negative 2y's here and I've got positive 2y's here. Cool. I love it when that happens. It's just going to be y to the 0. All right, let's see if we can simplify this anymore. We obviously can because these just turn into 1, and it would be 1 times 1, but of course we know 1 times 1 is just 1. So I'm going to write 1 plus, and then we've got another y to the 0 here, so I can basically just get rid of that and make it a 1. Of course, it doesn't matter. When you multiply by 1, it's just the thing itself. So I'm going to bring down the 4x squared. So my answer is 1 plus 4x squared. And that's as much as I can simplify it. All right, let's make sure that you understand that raising something to the 0 because you know those test makers and they are tricky. And they're going to probably trick some of your friends, but they are not going to trick you. So let's do example 29.9 and look at these. What if you have 2 raised to the 0 power? Anything raised to the 0 power is 1. All right. What about this one, though? Negative 2 raised to the 0 power. Now I want you to notice where this negative sign is because it's kind of out front. When it's out front like that, when you can slide it over and make it out front, then it's kind of like saying, what is the opposite of that? So when you say, what is the opposite of that? It's going to be negative 1. That one's tricky. And it's because of where that is. Let's look at this one. If there's parentheses, and everything inside the parentheses is raised to the 0 power, then everything inside the parentheses is just 1. So this is just 1. And that's the final answer. So it depends on where that negative is. If it's inside the parentheses, it's going to turn to 1, like that. If it's outside the parentheses, or if there are no parentheses and you can just slide that guy over, then it means the opposite of this, which is -1. Does that make sense? Hopefully that makes sense. If it doesn't, text me, let me know. And guess what? That's the whole lesson today. All right. Thanks, Addie. Hope you enjoyed it. Love ya. Bye.